Hello, welcome to Tech Unplugged.
Great to be here.
Today, we're embarking on a deep dive into the connected worlds of authentication and authorization, specifically single sign-on and OAuth.
Right. Two really foundational concepts in modern security.
Exactly. We've got a lot of ground to cover based on the information you've shared, and our aim is to, synthesize it all, pull out the essential insights and connections you need without getting too bogged down in the weeds.
Yeah, and what's fascinating, I think, is that while both SSO and Oath deal with access, they're actually tackling fundamentally different questions. SSO is about who you are, verifying identity.
And OAuth is about what you're allowed to do, authorization.
Precisely. Delegation of permissions.
Okay, so let's start with single sign-on, or SSO. That incredibly convenient system, right? Access multiple apps, one login.
The dream for users, definitely.
We'll explore how it works, but also the core technologies behind it, things like OpenID, SAML, and the newer OpenID Connect.
It's useful to think of it less like just a login and more like establishing this central, trusted digital identity that other services can then recognize.
That makes sense.
And the real impact of SSO goes way beyond just making logins easier.
Yeah.
It fundamentally changes how organizations manage access.
How so?
Well, it shifts things from this potentially chaotic mess of individual accounts everywhere to a much more unified, auditable identity layer.
Right, okay. Then after SSO, we'll navigate into OAuth territory, which is more nuanced, I suppose.
Yeah.
This is where we look at how one app gets like limited access to resources on another service for you, but without you handing over your main password.
Yeah, the classic example is letting a third-party app access your Google Drive files or your Twitter feed. You don't give that app your Google or Twitter password.
Exactly that. So we'll clarify the big jump from OAuth 1.0 to the now standard 2.0, look at common security traps, vulnerabilities,
Which are definitely out there if you're not careful with implementation.
and highlight the crucial best practices to keep things secure.
Essential stuff.
And finally, we'll briefly touch on identity as a service, IDAS. Because in today's cloud world, it's playing a bigger and bigger role, isn't it?
It absolutely is. It ties a lot of this together for many organizations.
Okay, sounds like a plan. Let's dive in, starting with single sign-on. At its core, what is SSO?
Okay, so fundamentally, SSO is an intelligent authentication system. It's built for efficiency, yes, but also for better security management.
So you log in once?
Right, using whatever method password, maybe biometrics, multi-factor auth. And that initial successful login grants you seamless access to a whole bunch of other connected applications and services.
Without having to log in again and again.
Exactly. No repeated logins needed for those linked services.
Which is why users love it. It gets rid of that horrible feeling of juggling, dozens, hundreds of passwords sometimes.
Oh, absolutely.
Okay.
It directly tackles that password fatigue we all feel. SSO acts like this central digital gatekeeper, or maybe digital passport.
I like the passport analogy.
Yeah, it verifies you once, then quietly vouches for you as you move between different authorized places online.
It's a huge win for user experience, definitely.
No question. And for the organization, the IT teams, the benefits for managing access are massive.
How so?
Well, think about it. Instead of grappling with this sprawling web of individual logins for every single employee across every single app.
Which must be a nightmare.
It is.
Yeah.
SSO consolidates all that. It gives you a much clearer, more manageable view of who has access to what. That centralization is absolutely key, both for efficiency and for security oversight.
Okay, that makes sense. Now, you mentioned technologies that make SSO work. OpenID, SAML, OpenID Connect. Can you break those down for us?
Sure. Let's start with OpenID. Think of it as one of the earlier attempts to standardize digital identity across different websites.
Okay.
The idea was you'd have one identity provider. That's the place that knows who you are, and it can vouch for you, verify your identity for other websites, which we call service providers.
Right.
It was pretty groundbreaking for its time, but honestly, most of its core ideas and functions have now been sort of absorbed and improved upon by OpenID Connect.
So OpenID laid some groundwork, but is less common now?
Pretty much, yeah. You don't see pure OpenID deployed as much these days.
Okay. What about SAML? That sounds familiar, especially from corporate environments.
That's exactly right. SAML security assertion markup language, it's been around longer. It's an XML-based standard, both a data format and a protocol, designed specifically for exchanging authentication and authorization data securely between parties.
XML-based, okay.
And it's been a real cornerstone of enterprise SSO for many years. It's quite robust. Interestingly, Even very modern tech companies like Google still use SAML quite extensively.
Oh, really?
Yeah, especially for federating identities between different organizations or integrating with big third-party enterprise apps.
Hmm.
SAML's strength is in its established standards for these secure assertions, basically, statements about the user's identity and permissions.
Huh. It's interesting that something XML-based is still so central.
It is, but it works well for those complex enterprise scenarios. Now, OpenID Connect, or OIDC,
That's the newer one.
that's the latest generation.
Yeah.
And importantly, it's built directly on top of the OAuth 2.0 framework, which we'll talk about later.
Oh, okay. So they're related.
Very much so. OIDC is essentially a more modern, streamlined, and often simpler evolution of the original OpenID ideas. Its design feels a bit like, those login with Facebook or login with Google buttons.
Yeah, exactly.
It's gained huge adoption from all the major identity providers, Google, Microsoft, Okta, you name it. A key advantage is that it's built for the web and mobile, uses JSON, which developers generally prefer over XML, and it can provide basic user profile information along with the authentication confirmation, all in a standard way.
So, quick recap. OpenID was early days, SAML is the enterprise workhorse, often XML, and OIDC is the modern OAuth-based layer, very web mobile friendly.
Like a pretty good summary, yeah.
Great. So, moving on from the tech, what are the big benefits for an organization putting SSO in place?
The advantages are really significant. Top of the list, as we touched on, is that centralized identity management.
Right.
And that directly simplifies compliance, massively,
How does it help with compliance?
because you have a single authoritative source for user authentication and access events.
Yeah.
It gives you a unified, easily auditable record of who logged in when and potentially what they accessed across multiple systems. Generating reports for audits becomes so much easier.
Instead of trying to piece together logs from dozens of different apps.
Exactly. It cuts down that complexity enormously.
Mhm.
Think about demonstrating compliance with regulations like SOX or GDPR. Having that central view is invaluable.
Okay, huge benefit there. What else?
Another critical one is better security through real-time monitoring and logging, because everyone funnels through the SSO system.
You get one place to watch.
Precisely. You get a central vantage point to observe user activity across all the connected applications.
Mhm.
You can track logins, failed attempts, maybe even high-level resource usage, all in near real time,
So you can spot weird stuff faster.
much faster. It allows for quicker detection of suspicious or unauthorized behavior. That visibility is a powerful deterrent in itself, and it's critical for responding quickly if something does go wrong.
Better oversight, faster threat detection, makes total sense. Now, the information we looked at also mentioned platforms like Zluri in this context. How do they fit in with SSO tools like, say, Okta?
Right, so tools like Zluri provide a really important management layer that sits alongside or integrates with your core SSO provider like Okta or Azure AD.
Okay, so they're not the SSO provider itself.
Generally, no. While Okta is handling the actual login and authentication, Zluri focuses more on the broader lifecycle management of all your SaaS applications and the user identities within them. They connect to the SSO system.
What kind of management?
Things like discovering all the SaaS apps being used, even shadow IT sometimes, tracking usage, optimizing licenses, but importantly in this context, identifying security risks within those connected apps and streamlining processes like onboarding and, crucially, offboarding users.
Offboarding. That came up specifically. Zluri's process was highlighted. What's special about it?
They emphasize this comprehensive, multi-step approach when an employee leaves. It's not just disabling the SSO login.
What does it involve?
It includes things like immediately revoking access on any devices the user had enrolled, which is often overlooked. Then, critically, backing up the user's data from key SaaS apps.
Before deleting anything.
Exactly. Then transferring ownership of files, projects, contacts, whatever is needed for business continuity. And then finally, deprovisioning the account across all the connected systems via the SSO integration.
That sounds much more thorough than just flipping a switch in the SSO tool.
It is. It aims to close security gaps quickly and ensure data isn't lost or left inaccessible when someone leaves. Minimizes risk.
Makes sense. And you mentioned these platforms also help find security risks in the SaaS apps. How does that work?
Yeah, so they continuously monitor the configuration and usage patterns within the applications linked to your SSO.
Looking for what?
Things like users with excessive permissions, apps holding sensitive data that maybe haven't been used in months, configurations that don't meet security best practices, identifying risky third-party app integrations connected via OAuth.
Connecting back to OAuth there.
Yep. They provide this centralized dashboard view flagging potential issues so IT can investigate. It's about getting visibility beyond just the login event provided by SSO.
So SSO simplifies access, and these management tools help govern and secure what happens after the login. A powerful combo.
Definitely a strong synergy when used together.
Now, the info also touched on practical SSO implementations. Unix, Linux with Kerberos, smart cards, Windows. Can you briefly explain those?
Sure. In the Unix-Linux world, Kerberos is a very common network authentication protocol used for SSO. When you log in, often via something called PAM modules, your system gets a special Kerberos credential called a ticket granting ticket, or TGT.
TGT, got it.
That TGT then acts like a master key for a limited time, allowing you to access other Kerberos-enabled services, file share service applications, without re-entering your password.
Okay. And smart cards.
Smart Card SSO uses a physical card, often with a chip, for the initial login. You might insert the card and enter a PIN.
Right, like a bank card.
Similar idea. The card holds digital certificates or keys. Once you're authenticated using the card, subsequent applications that are integrated can recognize that secure session established by the card. Again, no extra password prompts.
And Windows. That seems like it would be built in.
It often is through something called Integrated Windows Authentication, or IWA. If you're logged into a Windows computer that's part of a domain, IWA can automatically use your Windows login credentials to authenticate you to other network resources, like file servers, printers, or internal websites, seamlessly.
So different systems, different mechanisms, but the same goal. Log in once.
That's the essence of it, yeah. Tailored approaches for different environments.
Okay. But no technology is perfect. What are the downsides or criticisms of SSO? The challenges?
Yeah, it's really important to be realistic. SSO isn't magic, and it brings its own set of potential problems. One area is social engineering risk.
How so?
Well, if users get too used to just one password and then forget it, what happens? They call the help desk.
Right. Lots of calls.
Exactly. And if the help desk is overwhelmed or doesn't have really strict verification procedures for every single reset request, they become a prime target for attackers trying to trick them into resetting the wrong person's password.
Ah, so the convenience could lead to a bottleneck that attackers exploit?
Potentially, yes.
Yeah.
That's why having robust, secure, ideally automated self-service password reset systems is crucial alongside SSO. It takes the pressure off the help desk.
Good point. What about the bigger security picture? Is having one login for everything inherently risky?
That's the classic all eggs in one basket concern, and it's valid. If that central SSO system itself gets compromised,
The attacker gets the keys to the kingdom?
pretty much,
Yeah.
they could potentially access a huge range of connected systems and data. So the security of the SSO platform itself has to be absolutely top-notch. Multiple factors of authentication, strong monitoring, rapid patching, the works. The overall security is only as strong as that central SSO system.
Definitely highlights the need for serious defense in depth around the SSO solution. What about just setting it up? Is it easy?
Not always. Implementation can be complex,
Yeah.
especially in larger organizations with lots of different types of applications, old legacy apps, modern SaaS apps.
Yeah, mixed bag.
And integrating with different identity providers or ADPs. You mentioned Okta, there's Azure AD, Ping Identity, etc. They don't all work exactly the same way.
Yeah.
There can be quirks.
So getting them all to talk nicely isn't guaranteed.
It often requires configuration effort,
Ah.
maybe maintaining slightly different setups for different IDPs. Plus, you might still have some users who aren't in the SSO system, maybe contractors or specific roles, using old-school username password logins for some apps. Managing that mix adds complexity.
Okay, so integration isn't always plug and play. The info specifically called out challenges with SAML implementations.
Yes, SAML, while powerful, has a degree of flexibility that can sometimes be, well, a double-edged sword. Because that flexibility means different vendors might implement parts of the standard slightly differently. How they structure the XML assertions, how they handle digital certificates for signing or encryption.
Little variations.
Little variations that can lead to interoperability problems, getting systems from two different vendors to talk SAML smoothly, or even subtle security gaps if not handled carefully. The complexity of some SAML payloads and certificate management can make consistent, secure implementation tricky sometimes.
Sounds like it can lead to integration headaches and potential blind spots if you're not careful.
Yeah.
What about setting up SAML with a new partner or customer?
Yeah, that onboarding process for new enterprise customers using SAML can be surprisingly challenging. It involves exchanging a bunch of technical details, entity IDs, assertion consumer service URLs, attribute mappings, security certificates.
Lots of jargon.
Exactly. And there isn't always one single, universally agreed upon way to format or define all these parameters. It can lead to back and forth, misconfigurations, and require quite a bit of manual setup and testing to get that trust relationship working. Even simple things like, how should the certificate be uploaded, aren't perfectly standardized in SAML itself.
So, a lot of potential for manual fiddling and crossed wires during setup.
It can definitely happen. Clear documentation and communication are key.
And what about managing the user session after they've logged in via SAML? Any issues there?
That's another subtle point. SAML is great at handling the initial login, the authentication event, but figuring out later if that user session is still valid and active across all the different connected applications, that's not always straightforward within the SAML protocol itself.
So, knowing if they're still logged in securely everywhere?
Right. And managing session timeouts. How long should a session last before the user has to log in again? Balancing security, short timeouts, with user convenience, longer timeouts, requires careful thought and sometimes relies on mechanisms outside of basic MLL.
Okay, so ongoing session management needs attention too. Lastly, on SSO challenges. Offboarding. We touched on Zaluri helping, but what are the core issues when someone leaves?
Offboarding in an SSO world needs a really clear, well-executed process. You absolutely must ensure their access is revoked everywhere, immediately.
Not just the main SSO login.
No, you need to ensure all active sessions they might have open in various apps are terminated. Otherwise, they could potentially still access things for a while after their main account is disabled.
Right.
Then there's the data question: what happens to their files, their emails, projects they own? Does it get archived, transferred? And what about shared resources? If they had admin rights somewhere, those need to be revoked or reassigned. Failing to do this properly leaves significant security holes.
So SSO simplifies the in but complicates the out if you're not careful.
You could say that. It requires a more holistic approach to deprovisioning.
Okay, that's a great overview of SSO, the good, the bad, the tech. Let's shift gears now to OAuth. What's the fundamental idea behind OAuth?
Okay, OAuth, open authorization. The key word is authorization. It's not primarily about logging you in. That's SSO's job, often with OpenID Connect layered on OAuth. Oath is about granting permission.
Permission for what?
Permission for one application could be a mobile app, a website, anything to access specific resources hosted by another server on your behalf. And the crucial part, it does this without you ever giving your actual password for that resource server to the first application.
Right, the example you gave earlier, letting a photo printing app access your Google Photos, but not giving the printer your Google password.
Exactly that. It's secure, delegated access. The app gets a temporary key, an access token, that only works for specific things you allowed, like maybe just reading your photos, not deleting them, or accessing your email.
Okay, delegated permission. Now, the info contrasted OAuth 1.0 and 2.0. Why is 2.0 the standard now? What was wrong with 1.0?
Well, OAuth 1.0 did achieve that core goal of delegated access without sharing passwords. It worked. But it was quite complex, especially for the application developers, the consumers, to implement correctly. It involved a complicated multi-step dance with temporary tokens and generating cryptographic signatures for every single request.
Sign-in request. That sounds fiddly.
It really was.
Yeah.
Developers had to manage cryptographic keys, correctly sign request parameters in a specific order. It was error-prone. And importantly, it was originally designed to work over plain HTTP, relying on the signatures for security, which isn't ideal.
Ah, okay. So how did OAuth 2.0 improve things?
OAuth 2.0 is more of an authorization framework than a single rigid protocol. It simplified the flows significantly. It introduced different ways to get authorization, these grant types we'll talk about, tailored for different kinds of applications, web apps, mobile apps, server to server.
More flexibility.
Much more flexibility. And a huge security improvement was ditching the need for the client application to do complex cryptographic signing on every request. Instead, it relies heavily on using HTTPS secure encrypted connections for everything.
So security is baked in via TLS HTTPS.
That's the foundation. And instead of complex signing, it uses bearer tokens specifically, short-lived access tokens. The app gets a token and just presents it to access the resource. It also introduced refresh tokens to allow apps to get new access tokens without bothering the user again every hour or so.
Simpler flow, HTTPS mandatory, short-lived access tokens, refresh tokens. Sounds much more practical.
It is much more scalable, much better suited for mobile apps, which exploded around the time 2.0 was developed. That practicality and better security alignment led to its widespread adoption. OAuth 1.0 is pretty much deprecated now.
Okay, that makes the evolution clear. You mentioned grant types in Oath with Coino several times. Can you walk us through the main ones?
Sure. Probably the most common one for traditional web applications is the authorization code grant.
How does that work?
You, the user, get sent from the application, the client, to the authorization server, like Google's login page. You log in there, approve the request, and Google sends you back to the application with a temporary, one-time use authorization code.
Okay.
The application then, on the back end, securely exchanges that code directly with Google for the actual access token. It's secure because the token isn't exposed in the browser, only the temporary code is.
Got it. What about mobile apps? They can't always keep secrets easily.
Right. For public clients like mobile apps or single-page web apps running in the browser, there's a crucial extension called PKCE, Proof Key for Code Exchange.
PKCE.
Yeah, it adds an extra verification step to the authorization code flow that prevents attackers from intercepting and using that authorization code, even if it leaks somehow. It's basically mandatory now for public clients.
Okay, so authorization code, often with PKCE. What else?
There's the Resource Owner Password Credentials Grant, or ROPC. This is where the application directly asks you for your username and password for the service.
Wait, I thought the whole point was not to do that.
Exactly. That's why ROPC is strongly discouraged. It bypasses the main benefit of OAuth. It should only ever be used if the application is completely trusted, like maybe an official app from the service provider itself. And even then, only over HTTPS, and ideally with very short-lived tokens. Generally, avoid it.
Okay, avoid ROPC. Next.
The Client Credentials Grant. This isn't for user access. This is for machine-to-machine communication. Like, one backend service needs to talk to another API it owns or has permission for without a user involved. The service authenticates itself using its own client ID and secret to get a token.
Server-to-server stuff. Makes sense.
Then there's the Device Code Grant, sometimes called the device flow. Think smart TVs, printers, command line tools, devices where typing a password is hard or impossible.
How does that work?
The device shows you a short code and a URL. You go to that URL on your phone or computer, log in normally, enter the code, and approve access. The device back on the TV then gets the token.
Clever. Okay, one more.
The Refresh Token Grant. This isn't for initial authorization, but for getting new access tokens after the first one expires. Access tokens are deliberately short-lived for security. When one expires, the application can use the longer-lived refresh token, which it got earlier, to request a new access token from the authorization server without making the user log in all over again.
Ah, so that's how apps stay logged in for weeks or months.
Pretty much, yeah. Though managing refresh tokens securely is also really important.
Okay, that covers the main ways OAuth 2.0 grants access.
Now, security. Since it's everywhere, it must be a target. What are the common vulnerabilities?
Absolutely. Its popularity makes it a big target, and yeah, misconfigurations are the root cause of many issues.
Like what?
One is authorization code injection. If an attacker can somehow steal that temporary authorization code before the legitimate app uses it.
They could potentially exchange it for an access token themselves.
Exactly. This is where PKCE is a crucial defense. Also, using a nonce parameter, especially with OpenID Connect, helps prevent replay attacks with codes.
Okay. Redirect URI validation is huge. When the authorization server sends the user back to the application with the code or token, it uses a pre-registered redirect URI. If the server doesn't strictly validate that URI, or if the application has an open redirect vulnerability.
An attacker could trick the server into sending the code to their malicious site instead.
Precisely. That's a common way to steal codes or tokens. Both the authorization server and the client need strict URI validation. Only allow redirects to known, safe locations.
Critical check. Keep going.
Cross-site request forgery, CSRF. An attacker could trick an already logged-in user into clicking a malicious link that makes an unintended request to the client application's redirect URI, potentially completing an OAuth flow the user didn't intend. Using the state parameter properly in OAuth is the primary defense here.
Okay, CSRF is another angle. What about the tokens themselves?
Access tokens can be leaked, maybe through insecure logging on the resource server, or intercepted if not sent over HTTPS, though 2.0 mandates HTTPS. If an attacker gets a valid access token, they can use it until it expires.
So protecting the token is vital.
Absolutely. Using techniques like sender-constrained tokens, where the token is tied cryptographically to the client making the request, using things like mutual TLS or deep IP, makes stolen tokens much less useful. Also, ensuring tokens have a narrow audience, meaning they only work for the intended resource server, helps limit damage.
Sender-constrained, audience-restricted tokens. Good points. What about refresh tokens?
Refresh tokens are very valuable targets because they last longer and can be used to get new access tokens repeatedly. If one is stolen, the attacker might have long-term access. Protecting refresh tokens is paramount, and authorization servers should try to detect if a refresh token is being used suspiciously from multiple locations and revoke it and related access tokens if needed.
High value targets, those refresh tokens. Anything else?
Clickjacking. This is where an attacker overlays invisible malicious elements on top of a legitimate website, tricking the user into clicking something they didn't intend to, like the approve button on an OAuth consent screen.
Sneaky. How do you stop that?
Using standard web security headers like X-frame options or Content Security Policy, CSP, to prevent your authorization pages from being loaded inside malicious iframes.
Okay, a whole range of potential pitfalls. Seems like getting OAuth right requires careful attention to detail. What are the official best practices then? You mentioned RFC 9700.
Yeah, that RC consolidates current security best practices. Key takeaways are: clients must use PKCE, preferably with the S256 challenge method because it doesn't expose the secret. Authorization servers must support and enforce PKCE if the client sends a challenge.
PKCE everywhere for public clients. Got it.
Servers should use sender-constrained access tokens like MTLS or DPIP whenever possible. Clients must validate redirect URIs carefully. Authorization servers must only redirect to explicitly trusted pre-registered URIs.
Strict URI handling on both sides.
Refresh tokens must be protected. Servers should detect replay misuse and revoke tokens if needed. And finally, authorization servers must prevent clickjacking using those headers we mentioned. X-frame options, CSP level 2+.
Sounds like a solid checklist for secure implementation. You mentioned earlier how mobile really drove OAuth adoption. Can you expand on that connection?
Definitely. Before smartphones really took off, a lot of enterprise security was built around the idea of a secure internal network perimeter VPNs, firewalls.
Right, the castle wall model.
Exactly. And protocols like SAP and SAML, often using XML, were common for internal service communication. But mobile apps live outside that perimeter. They talk directly over the internet, usually using HTTP and lightweight formats like JSON.
A totally different world.
Totally. OAuth, being HTTP native, using JSON-friendly tokens, and designed for delegated access without passwords, was just a perfect fit for this new mobile-first world. It provided a standard, secure way for all these new apps to talk to back-end APIs and access user data, handling both the authentication piece, usually via OIDC on top, and that crucial user consent authorization step.
So the mobile revolution basically made OAuth essential infrastructure for the modern internet.
You could definitely argue that, yes. It underpins so much of how modern applications interact securely.
Okay, that covers OAuth nicely. Lastly, let's bring in identity as a service, IDEAS. How does this fit into the picture with SSO and OAuth?
IDEAS is essentially taking all the complex machinery of identity and access management user directories, authentication systems, SSO capabilities, access policy enforcement, logging, and offering it as a cloud-based subscription service.
So instead of building and running your own Okta or Active Directory Federation services on-premise,
You pay a provider like Okta, Azure AD, Auth, Ping Identity, etc., to handle it for you in the cloud. And they provide the infrastructure, keep it updated, manage the security, and you consume it as a service, usually via APIs.
okay, outsourcing identity management to the cloud, what are the benefits?
Scalability is a big one. You can easily handle more users or connect more applications without provisioning new servers. It also makes sophisticated IAM features, like advanced multi-factor authentication, adaptive access policies, and yes, robust SSO and OAuth capabilities, accessible to organizations of all sizes, not just large enterprises.
Democratizing enterprise-grade identity tech.
Exactly. It also significantly simplifies compliance efforts because the IDS provider handles much of the underlying infrastructure security and provides centralized logging and reporting tools designed for audits. You still have responsibilities, of course, but the platform helps a lot.
And presumably, they integrate well with standards like SAML, OpenID Connect, and OAuth.
Absolutely. That's core to their function.
Right.
They act as that central identity provider for SSO using SAML or OIDC, and they function as the authorization server for OAuth flows, managing clients, scopes, tokens, and user consent. They provide the engine that makes secure SSO and OAuth work across your applications.
So IDES takes the complexity of running the SSO auth infrastructure off your plate, delivering it as a scalable, compliant cloud service.
That's a great way to put it. It lets organizations focus on their actual business, knowing that identity and access are being handled by specialists, leveraging these modern standards securely.
Fantastic. So reflecting on all this, we've covered a huge amount. from SSO simplifying logins and the tech behind it, like SAML and OIDC.
Right, and the benefits like easier compliance and monitoring, but also the challenges around security, complexity, and especially offboarding.
To OAuth enabling secure delegated authorization, the vital shift from 1.0 to 2.0, the different grant
And
types.
those crucial security best practices like PKCE and proper URI validation to avoid common pitfalls.
And finally, seeing how Ideas provides a cloud-based platform to manage all of this effectively.
Hopefully weaving through all that information has brought some clarity, maybe connected some dots, and made these sometimes intimidating topics feel a bit more manageable.
I certainly feel like I have a much clearer picture. These aren't just abstract concepts. They're the plumbing that makes so much of our secure digital interaction possible today.
Absolutely. And it's a field that continues to evolve, so there's always more to learn.
Indeed. Well, that brings us to the end of this deep dive. Thanks for listening to Tech Unplugged. Stay tuned for more.